Scenario. Block A and C are at rest on a frictionless surface as shown. Block A is bigger than block C based on its size here. Block A is connected to a string that is tied to block B, and notice block B is hanging off that table over an ideal pulley. An ideal pulley here is considered to be massless and frictionless. So here's the question. I would like you to label the forces on block B. What is the force that is pulling it down? Here's the answer. The force of gravity on that block B is what's pulling it down, so we can label it as FBG. The next question. Label the internal forces in this system. Do they cancel? Well, here's the answer. There is force of tension on A and there's force of tension on B due to the ropes. And yes, they do cancel. The tension forces here cancel each other's out. Next, what is the force that causes block A to move? I would like you to write an equation for it. Here, we can look at the answer by looking and seeing that the force of gravity on block B is pulling block A and causing that to move. So, this equation just comes from, in your equation sheet, A is equal to the summation of F over M. I just multiplied M to the other side. But now there are multiple objects, so I looked at the system. So the mass is mass of B plus mass of A times the A of the system is equal to the summation of all the forces. The only force in this scenario is force of gravity. So that equals to FBG. Remember, the force tensions here cancels. There is no force friction. So it equals to FBG. Here's the question then. What is the force that's causing C to move? Because if you let the system go, B is going to fall down and C is going to be moved. But the rope is on A. Why does C move? Well, C will move if we add it to the system. So the system's mass, I just add MC, and we just set that equal to the force of BG. Okay? Notice that in theory, this is going to be slower than this A system, because this A system has 3 masses. This system has 2 masses. Okay? Now, you want to look at the acceleration, so you want to now solve for this. To solve for it, you just have to divide by mass to both sides. So A of the system is equal to FBG divided by the system's mass. Notice, as you increase the mass, the acceleration is going to go down because the force remains the same and is the force of the block of B. To increase this, you would want to increase the mass of B. That's going to get you a greater force to pull it down. All right? There you go.